Hello, everyone. This is my experience of report on using F# for business domain modeling. My name is Scott Bloshen. That's my Twitter handle. And I also have a website called fsharpforfunandprofit.com. So just to sort of set the stage, I wanted to differentiate between languages with a mathematical focus and languages with more of a business focus. And of course, on the mathematical side, we have proof assistance, we have functional programming languages, and so on. On the business side, we have COBOL, and nowadays we also have Java and C# and so on. Now, I've had very good experience using F# as a business language, basically using F# as a replacement for COBOL or Java. And so that's what I want to talk about today. So in business-focused development, it's slightly different emphasis than other types of development because understanding the domain is the most important thing. We have stacks of paper, you have policies, you have rules, all this stuff needs to be understood. Getting it correct is actually not as important as getting it right, as understanding what you're doing. And the other thing is these policies and these rules change all the time. So responding to feedback is very important, and you need to adjust your domain model as things change very quickly. So F# is fantastic for this, I think. First of all, the code is very readable by non-developers. I'm going to be using types code. I'm not talking about the implementation in detail. And it's very easy to collaborate with non-developers. I use composable types for domain modeling. I call them composable. You'll see why in a minute. And of course, we've got type checking. It makes it very easy to refactor and change things as the rules and the policies change too. And finally, I want to quickly talk about how you can eliminate errors through at the design time rather than at runtime. And this is often called making illegal states unrepresentable. So let's start with collaboration. I use a process called domain-driven design, and let me just give you some background on that first. Traditional software development was using something called Waterfall methodology, where you had domain experts who were taught to analysts who would write up requirements, who were taught to other people. Eventually, it comes down to the developers who write the code. This is really a bad process because there's no shared mental model, there's no feedback, there's no chance to fix misunderstandings. So often these projects fail due to misunderstandings between the domain experts and the actual code. Now, what's happened in the last 20 years or so is Agile methodology, which is much better. It encourages the domain experts and the developers to talk to each other and to have frequent deliverables and fast feedback loops. So that's much less likely to have problems. However, even in Agile, the code is still the developer's version of the code, and developers can often mistranslate their understanding into the code. So in domain-driven design, the idea here is that everybody involved has the same shared mental model. There's a shared mental model which the domain experts use, the developers use, shared language, shared concepts. Everybody is using this same mental model. And in my experience, if people do not have the same shared mental model and they do not use the same words and same concepts, the project is very likely to fail. In my experience, more projects fail due to misunderstanding than things like correctness. Correctness is not normally the reason why projects fail. And also in this design, the code is part of the shared mental model. The code also has the same shared language and the same shared concepts. So people immediately say, well, how can you make code, represent this code? This is what people think code looks like, right? Code looks impenetrable. But let me show you the kind of code I'm talking about. This is the kind of code I'm talking about. This is domain-driven code. And even if you know nothing about F#, you can understand what the concepts are. We have our shared language. The shared concepts are the type definitions, basically. So this is really easy for non-developers to understand what's going on here. One thing I should just point out is not just data, but I'm using function types to represent business workflows or stories that people need to do. So here I have to deal a card or to pick up a card. These are activities or verbs that I'm modeling with function types. So when I do my domain modeling, I actually work with non-programmers and they can understand this. And in fact, one person once said, there's great documentation, but where's the code? So that was nice. And the other thing is that when you're working with domain experts, they can actually give you useful feedback, even though they're not a programmer. So if you're a poker expert you would notice straight away that there's actually a deliberate mistake in this design. And a poker expert would point out straight away that you've missed out the ace. And without having to be a programmer, they can give you feedback on the domain, whether you got the domain right or not. Now, as I said at the beginning, getting rapid feedback is a really important part of the process. And rather than getting feedback in days or months, it's really nice to get feedback in minutes. So when I do my domain modeling process, I actually do it as a collaborative process. We have a shared room and I'm presenting onto a whiteboard or onto a projector or something. Everybody is in this room, not just the developers, but the domain experts, the testers, the product owners, all this stuff. And what happens is I type up, as we work through the domain model, I type stuff up on the screen and everyone can see what I'm doing and everyone can give me feedback. So I would say, okay, this is how you deal. This is how I think you deal. And one of the domain experts might actually say, that's not right. We don't deal in poker. We don't use a normal deck. We use a shuffle deck. And I say, oh, okay, a shuffle deck. So I put down a shuffle deck. And they say, yeah, that's right. And then I say, okay, so what is a shuffle deck? Well, that's just a list of cards. So I write down that. So I've learned a new concept that I didn't necessarily know before. And then I might say, well, how do you create a shuffle deck, right? Well, they will say it's really obvious. You shuffle. So it's obvious to the expert, but it's not obvious to me as a developer who's not familiar with the domain. So I now have this concept called shuffling, where the input is a deck and the output is a shuffle deck. So I've just learned 2 new concepts in a couple of minutes of discussion with people that I might not have known before, and it would have actually been a bug. Really, using an unshuffled deck could actually be a serious bug in a poker game. So this is an example of the design process happening fast, interactively. We haven't written any code yet, but everyone is sharing knowledge. Everyone is becoming expert in the domain. Now, the way I explain domain modeling to non-programmers is calling it a composable type system, right? We're using an algebraic type system, but I prefer to call it composable. It sounds a little less scary to non-mathematicians. So, and I explained that you can build bigger types and smaller types using and using or. So and would be a product type, a record type, and or would be a sum type. I like to call them choices. So here's an example of how I might actually do this. I might say that we have requirements to accept 3 forms of payment: cash, PayPal, credit cards. And for PayPal, we need an email address. And for credit cards, we need card type and card number and all the other information. So how would I model this in F#? Well, I would use this compositional approach, right? I'd start off with some simple types. I would not use primitives. I always like to wrap to put an alias around the primitives because people do not talk about strings and floats. They talk about email addresses and card numbers and so on. So we have our aliases. We have a choice, Visa or MasterCard. We have a record type, a card type, and a card number, right? So I'm using a choice and I'm using a record here. And then the payment method would be a choice, right? Cash or PayPal or card. And again, I would call this a choice type to people. I wouldn't call it a sum type or a co-product, right? I would just call it a choice. We can keep going. Of course, you just keep going and going because it's composition. I can add some more basic types, and I can say a payment is an amount and a currency and a payment method. And so what I've done here is I built a big type from a bunch of smaller types. And I find that, again, working with non-developers, this is actually fantastic. They find this very easy to understand. It's actually a much easier model than object-oriented programming for them, actually. It's also very easy to change because, of course, this is actually this all static type. So if I change something here, I get the rest of my code fails to compile until I fix up the errors and so on. So it makes it easy to understand, but it's also very safe from a programming point of view. So the final thing I want to talk about is how to eliminate errors through the design process. And this is often called making illegal states unrepresentable. So here we have an example of an email contact where we have an email address and we have some sort of flag to prove that they've been verified. Like, when you sign up for something, they send you an email link and you have to click the link to prove you own that email. So there's some business rules associated with this. The first rule is if you change your email address, you have to set that flag back to false because it's not verified anymore. And the second rule is that you should really only set that flag when it's gone through the special verification service that you've actually proved that you've clicked on that link. So that's not true with this design, because anyone can set that Boolean flag. So this is it's a bad design. It's insecure. You could easily have states in this design which are not meant to be occurring in the real world. So how can we fix this? I'm going to refactor it. So the first thing I'm going to do is create a new type for the email address. I'm going to wrap a string, and I'm going to use a single case union for that, or I could just use a very simple record type for that. But there would be some sort of associated smart constructor which would validate the email address, make sure it has an @ sign in it, and so on. The next thing I'm going to do is create another type for the verified email, and I'm just going to wrap a normal email address. The reason I'm doing this is because a verified email is a different concept in the domain than a normal email. It has a different behavior, different business rules around with it. Next, I'm going to model the verification service, and I'm going to say that is something which takes in an email address and some sort of hash as the input, and the output is an optional email because it might not work. And then finally, I can go back and I can refactor this email contact information to be a choice between unverified and verified. So I've got rid of the Boolean and replaced it with a choice between two cases. Now, in the unverified case, I can create that case. All I need for that case is a normal email address, so that's not a problem. But to create the verified case, I have to have a verified email. And with a little bit of tweaking, I can ensure that the only way to get a verified email is as the output of the verification service. I can make it an opaque type or something like that. So if I do this design, I've now enforced the business rules automatically. It is not possible to, if I change my email address, it has to be unverified. And the only way it can be verified if it's gone through the verification service. So I don't have to write any tests. I literally can't have a bug where I have done the wrong thing. So this is really, really nice. So just to summarize, I think algebraic types are excellent for business-focused domain modeling. Non-developers can really contribute to the process, and I think that's key to the success of a business project, of an enterprise type development. And finally, I think there's so much potential for ML languages here. There's a couple of things that would make my life easier, like make it easier to do smart constructors and so on. But I think there's a lot of potential, and I've actually written a whole book about it called Domain Modeling Made Functional. So thanks very much.